For 10.1, so we're going to go back a little bit now. So we've been talking about putting these numbers on graphs, you X and Y. You always go over first, then up or down. So we're going to talk about this here, how you might make a set of ordered pairs to put on and show different graphs from equations. So the distance in meters that Keisha hikes in X minutes is represented by this equation. So X is our minutes, Y is our meters. So every time she does this, this happens. Every time she does this, this happens. And we can use this equation to give ourselves a set of repeated numbers here. So every time she goes this many minutes, she makes 75. That will give us our meters here. So we know right here, X is 5. So we can do 75 times 5, and that will give us this first one here. We're just plugging this in. We know 5 is X. Now if she goes for 15 minutes, so now I can do 75 times 15 and find this one here. So now we're going backwards. If we have, this is Y, is 1,500, we know she's going to do 75X. Now we're looking for X. So we want X by itself. We've done these before. This means 75 times groups of X, so we want to undo it with the opposite of divisions, right? That 75 divided by 75 is 1, so we have 1 X left. And now we need to divide by 75 over here. So 1,500 dividing by 75. So let's make a list of 75s. So another 75, right? Because I know 25 gets me to 100. 50 more is 150. So plus 50 is to 200. And then I need 25 more is 225. So I need something above the 1, the 5, the 0, and the 0. I know it can't go into 1, can't go into 5, but look, it goes into 150 2 times. Perfect. And then we're bringing this down, and it can't go in there, so it goes in there perfectly 20 times. So if they go for 20 minutes, they go 1,500 meters. So see if you can do this one, right? We're doing backwards. So when we know X, we're going to multiply. So when we want to go backwards on our table, the opposite of multiply is divide. So finish filling out your table here. Explain how did you find this one here. So explain what you did for this one is B. And then it asks you to explain how you found this one for C. And now we have this set of ordered pairs. X is this, Y is this, X is this, Y is this. And we know we go over, up, and down. So if we have this one here, right, I can put this one, I know is 20 and then 1,500. So I go over 20 minutes and up to 1,500. And you should get these other ones. And because it's an equation, the same thing is happening over and over again. You should have a nice, perfect straight line when you're done. So finish writing your ordered pairs from your table, graph them on your grid, and then they should connect into a straight line because it was a unit rate, same thing, a constant unit rate happening over and over again. Okay, we are also going to do our check for understanding on this page too. Do a few more practice here. So you do not have to worry about these dependent and independent variables. So we're just going to solve and complete the table here. So you do have to do this part and complete the table. So when they have this equation, P equals 2/5 of M, P is our number of pages that they read. How many minutes did they do that in? So 2/5 of a page per what M gives us the total pages. So we're just going to plug these in. So we know, right? M, if M is 10, That means I have 2/5 of 10. And then I can even simplify these. 5 goes into 5 one time and 2 times. 2 times 2 is 4 over 1, which just equals 4. So that means after 10 minutes, they've read 4 pages. So if we're working backwards here, we have this 8. So we read 8 pages, 2/5 of a page. How many minutes? So this means 2/5 times m. So we want to do the opposite of times, and we want to divide by 2/5. So this cancels out. 2/5 divided by 2/5 leaves us with just m. And now we need to do 8 divided by 2/5. So 8 over 1 divided by 2. Whoops, that was not a divide sign. Divided by 2/5. So I can do 8 divided by 2, but not 1 divided by 5 very nicely. So I'm going to take it and turn it into a multiplication problem and copy, dot, and flop. And then you can even simplify before you multiply that out. So see if you can finish that. So when we know P, we've got this multiplication problem, we have to turn it and divide. And when we know M, we just have to times because we're looking for P, and P's already by itself. So go ahead and finish that table there. And then number 2 says a box of cereal. A store sells a box of cereal for $3. Write an equation to relate the number of boxes to the total sales. So right, T's our total. So we know T's the total. It's going to be by itself. I can put it at the end or the beginning, doesn't matter. So right, I could flip this problem around and say 2/5 M equals P, same equation. So every time you buy a box of cereal, so one box B is $3. So 3B. And then if I bought 2 boxes, the total would be 6. If I bought 9 boxes, $3 per box, 3 times 9 would be 27. So there's our equation. We can also flip it and write it 3B equals T for the total here. And then we could make a graph of that as well, right? Here would be B, here would be T. So I could say, right, $3 per box, or if I buy, whoops, that's not what I wanted to do. So yeah, it is. So if I, right, buy 1 box, 1 times 3 would be 3. If I buy 2 boxes, it's 6. And it would make this perfect line if I'm graphing it over 1, up 3, over 2, up 6, over 3, up 9. And it's going to show that perfect line of my constant rate of boxes. So we can really just take these equations and these tables and turn them into graphs over, up and down, just like we've been practicing.